Hello everyone and welcome back. My name is Zek and today we're exploring relationship loading techniques in SQLAlchemy and how they translate into SQL queries. Understanding these techniques is key to optimizing database interactions in Python. So let's dive in, and don't forget to like and subscribe for more SQLAlchemy tutorials. If you want to see the actual code examples for these and other tutorials, you can check out my GitHub in the description below. If you're watching this video, I'm assuming you have a basic understanding of SQLAlchemy and relationships. So first off, we have all of our imports up here at the top, and then we have db URL, which is using SQLite, and this will create a local file called database.db. It's not created right now, but once we run this file, it will go ahead and create it. And then for our engine, we are passing the db URL, but we're also setting a parameter echo equal to true, so we can see all the queries being executed by our session. And then we go ahead and set up a session with session maker. Then we have our declarative base, and we have our two classes of user and post. And this user will have a list of posts, being a one-to-many relationship between the tables. And in both of these, I have a double underscore repr double underscore just to make it easier whenever it does print it out to the console for us. There are a few different ways to specify different kind of loading techniques. In this specific video, we'll be focusing on this lazy parameter in the relationship function. So first off, we have the select option, which is the default. So you don't need to provide this lazy equals select because this will be just the same as if you don't put anything at all. Using this select loading option will generate a separate query whenever we try to access this post instead of initially getting all of the posts whenever we query for our user. So this can be good when you have an application, let's say like a blogging platform where each user has a moderate number of posts, and you need to often display user information alongside with their posts, but not every time you access a user object. So we'll go ahead and scroll down here, and we'll go ahead and create a new user set equal to user. We'll give them the name of Bob, and then we'll specify this relationship of post equal to a list, and we'll create a post giving it content and saying this is the content for X as an F string. And we're doing a list comprehension for X in range 1 to 5. So we'll create 4 posts for this user. And then we will go ahead and add this user to our session and then go ahead and commit it. And then to show you this specific loading technique, we'll go ahead and say user is equal to session.query of our user, and we'll get the first entry, which in this case will be our only entry since we've only created one user. And then we'll print accessing our user and then print the actual user object. And then we'll have another print statement saying accessing the post specifically, and then print the user's posts. So we can go ahead and run this and see that it has a bunch of statements in here from SQLAlchemy. But what's important for us are these select statements. We can see this select statement right here is just selecting our user, and we're getting the first user from it, which is this line 44 right here. And we can see here that it's printing accessing user and printing our user Bob, since that's how we defined our representation up top. And then we have the print statement of accessing post specifically. And then after that, when we're trying to do user.post, it goes ahead and performs a query to get all of those posts. And then it prints it out. In this scenario, the select loading behavior is beneficial because it loads the posts only when you need to access the post attributes of a user. This is efficient for scenarios where you don't always need the related objects immediately, and the number of related objects is not too large. And since the related objects, or the posts in this case, are loaded only when explicitly accessed, it reduces initial query load. There is a downside to this where it can result in one query to fetch all of the users if you're getting more than one user, and then an additional query for each user to fetch their posts if you're trying to access the post of each user. This can lead to n+1 queries, n being the number of queries to get the post for each user, and then the +1 for the initial query to get all of the users. This wouldn't be ideal in a social media application with a lot of users and a high volume of posts. We can see an example of this if we do session.addAll and we have a list of users that's a list comprehension of 1,000 users, and each user has a list of 5 posts with another list comprehension inside. We can go ahead and commit this data and then go ahead and query for all of our users within our database. And then we'll go ahead and print out accessing all users' posts, and we'll say for user in users, we will access their posts. And so we can go ahead and run this again. And we can see a lot is happening here. So we ran this again, and now there's a lot more stuff in here than the first one that we tried. And we can see that it's performing this select statement with this user ID of 998, and it's doing it for all users since we tried to access the post from every single user that we have in our database. Performing all these queries like this is not optimal for your database. So if you frequently access user objects without needing their posts, this can lead to a large number of unnecessary queries, especially if each user has a high volume of posts. This can result in performance issues due to the overhead of executing many separate queries. We'll go ahead and execute this query again, but we'll go ahead and time it. So we'll go ahead and scroll back up to the top, and we'll add an import here from time import perf counter, and then we'll go ahead and scroll back down to the bottom. Then we will come down here and say start is equal to perf counter. This will get the current time as a float, so we can then use it later to see how long it took for something to happen. And then after that, we'll go below our for loop and say print, and we'll have done in perf counter minus start. This will just get how long it took in between. And we'll go ahead and move this up so it doesn't affect anything. And you can see we're starting this timer before we start our very first query here. And then we're ending the timer after we execute all of the queries from here. So we'll go ahead and comment this out so it doesn't create more entries for us. And then we will go ahead and run this again. And then we can see down here, it says done in 2.60655 with the rest of those numbers. This is saying that it took 2.6 seconds in order to execute this initial query and all of the individual queries that were here. It just took 2.6 seconds when we only have 1,000 users in our database and they each have 5 posts. That's not very optimal for a large database. There are some other factors that are included, but we won't focus on those for this video. So you can imagine if we have 10,000, a million, or even 10 million users in our database, each having more posts, something like Facebook or Instagram, then this will take significantly longer. But there is a way to speed this up when we want to do something in more moderate amounts like this. So this loading technique of just select is good in scenarios where the number of related objects is moderate or low. And you need to access these objects occasionally, but not always when you load the parent object. It's less suitable for situations where there are a large number of related objects, and you rarely need to access them, as it can lead to unnecessary queries and performance overhead. In some of those cases, other strategies like the dynamic loading technique or explicitly loading the data when needed might be more efficient. And so the next loading technique we'll get into is the selectin technique. And so we'll do that by coming over to our lazy parameter and changing this select to selectin. So once we have that, we'll go ahead and run this again and we'll see a difference. We can see that took significantly less time, about 0.18 seconds. But why? Well, if you scroll up, we can see the queries being performed here. There's the initial select for users, and then we're selecting all the posts where the user ID is in a list of user IDs instead of individual queries for each individual user. So this definitely speeds up the amount of time it takes to get all of the posts, but then again, you're also getting all of the data. And we can see here there was the one query for the users, another query for the subset of the users, where it seems like it's the first 1 to 500. And then another query is executed where it's the rest of the users that weren't in the first query. So this one goes from 501 to 1,000. So in total here, there's only 3 queries being performed. And by that happening, it's taking significantly less time. So we can see how that overhead of individual select statements can increase the amount of time it takes to perform all the queries. But in doing this, it gets all of the posts and loads them all. And so using this loading option does avoid the n+1 problem. But for a very large number of users, the n clause in the query can become inefficient and slow. This would be inefficient for very large datasets with complex relationships like large social media platforms. Once you access the post from this relationship, it loads all the posts from all users. With a large number of users and each user having a large amount of posts, this will not be very efficient. So we'll go ahead and test this by adding 10,000 users to our database, each having 50 posts. So we'll go ahead and run this. And it will take some time since we are creating a lot of users and a lot of posts. So I'll cut back whenever it's done. So we can see it finally finished inserting everything with 500,000 posts. And it's committing everything and just performed all the queries. It finished, and we can see that this selectin query right here is grouping the users by 500 to get all of the posts for those users. And we can see it took almost 21 seconds in order to get all of the posts from all 11,001 users, each with 50 posts. So it's not too bad, but it's not ideal, and you shouldn't really be doing this kind of query on a database, getting all the information like this. So the selectin loading technique is good when dealing with a moderate number of parent objects and their related child objects. So in this case, users and posts. And you need to access these related objects frequently. It's inefficient in scenarios with large numbers of parent objects, each having many child objects like what I demonstrated here. It can lead to loading an excessive amount of data and cause some performance issues. And so the next loading technique we're going to get into is the joined loading technique. This adds a join statement in the query to load both the users and their posts together in one query. This can be very useful for something like a blog application with users and getting their latest post. So you can imagine in your blog application where you frequently display a list of users along with their latest posts. Each user has multiple posts, but you're only interested in showing the most recent one for each user. So in this case, we change our posts to a latest post relationship where we have useList equals false, meaning this will be a one-to-one, and our lazy parameter is going to be joined. I've gone ahead and deleted the database from our last example to go ahead and start fresh. So down here, we're doing session.addAll of a list of users, and we're only making 10 users and giving them the latest post of a post with the content. This is the latest content. Then we go ahead and commit it, and we'll perform our query getting all of our users in our database. And for each user, we're putting their name and the content of their latest post. So we can go ahead and run this, and we can see that it printed the user and the content for that user. But if we go and scroll up in here a little bit, we can see the query that's being executed. We can see this doing a select statement here, and then it's doing a left outer join on posts, where the user ID is equal to the post.userid. And this is going to get all of the users, regardless if the users have posts or not, because this is a left outer join. And we will go over joins in another video. So we can change this back around to have a list of posts using this join technique. And then our session.addAll below, we'll go ahead and make it a list of users, each having 5 posts. We go and commit it, and we'll go ahead and query everything and then print out the username and the post, and we'll see what that query looks like. So we'll go ahead and delete this database, go ahead and restart it by running it again. And went ahead and create all the content. If we go and scroll back up, and we can see the query here is the same as what we saw earlier. Doing this kind of join retrieves both the user's information and their posts in a single database query, which is efficient for small data sets. But a downside to this is that the join can result in a very large and complex query, potentially impacting performance. The next loading technique we'll see is the raise or raise on SQL technique. So this makes it to where no query is performed at all for the relationship, and trying to access it raises an exception in your code. This can be very beneficial for security-sensitive applications where loading-related objects should be explicit. Something like a user management system with sensitive data. So here we have the example still with our user. We have a table now called sensitive information, which is just the same as the post table we had before. And we are using the lazy equals raise here because we don't want the sensitive information to be accessed by any general query. So we go and scroll down, and we have our session.addAll of all of our users. In this case, we're only having 10 now, and we're having all of the sensitive informations being included here. Then we go ahead and commit it. We will go ahead and query all of our users, and we'll loop over each user printing their name and trying to print all of the information they have that is sensitive. So we can go ahead and try running this. We can see in our try except block that the sensitive information cannot be accessed directly, and then the statement is being printed out here each time we try to access it. This is very useful for scenarios where loading related objects should be explicit and controlled. And we can do that by using the options function on our query. So if we really wanted this to be loaded, we could say .options here after our query of our user. And in here we can say something like joined load of user.sensitive informations. And we will need to import this joined load up top from SQLAlchemy.orm. Go ahead and throw that on there. And we'll head back down to the bottom. We'll go ahead and comment this out so it doesn't create new users. And we'll go ahead and run this again. And so whenever we do, it is printing out all of the sensitive information. And we will go over this options function in a later video. And one of the downsides to this is that it can lead to frequent exceptions if the relationship is accessed without proper handling. So applications where related objects are commonly needed, like a user's and posts, will cause frequent exceptions. So overall, the lazy equals raise is good in scenarios where accessing related objects should be done explicitly and with caution, such as when dealing with sensitive data. It's not suitable for situations where related objects are commonly accessed and are not sensitive, as it adds unnecessary complexity and potential for errors. And so the next loading technique we'll get into is the subquery loading technique. And for this, we'll go back to using our example of user and post. And the user will have a posts relationship, which will be a list of posts, and as the lazy parameter will be subquery. This will create a query inside of a query. This can be useful for moderate-sized datasets where a single query is preferable. So think something like a small forum with users and their posts, and you frequently need to display user information alongside with their posts, and the total number of users and posts is not excessively large. And so using this example, we'll go ahead and scroll down, and we'll do session.addAll, a list of users, and there will be 10 of them, with each user having a list of posts, and it being 5 posts each. Then we go ahead and commit it, and we'll go ahead and run this. And we can see that it finished inserting everything into the database. That is cool. And for now, we'll go ahead and comment this out. And then we'll come down here, and then we'll say users is equal to session.queryOverUser, getting all of them. And then we'll loop over each user in our list of users, and we will print the name. And then we will list over each post within the user's posts, and this will efficiently load the posts for all the queried users using the subquery. And we'll go ahead and print the content of each post. So we'll go ahead and run this, and we'll pull up our console, and we can see that it printed out the post for each user. So if we go ahead and scroll back up to the SQL query, we can see that it has this select statement. And when we get to this from clause, there's a parenthesis with another select statement. This is the subquery, and it's also joining on the post table. So this is beneficial because it efficiently loads all posts for the users in your query using a single additional subquery. So this subquery loading technique is good when dealing with a moderate number of parent objects and their related child objects, and you need to access these related objects frequently. It's inefficient in some scenarios with a large number of parent objects, each having many child objects, as it can lead to complex subqueries and even performance issues. The next loading technique we'll get into is the write-only. So this will make it to where we cannot read or see what these posts are, but we can add new posts to this relationship. This could be very beneficial in, let's say, a logging system where we have users and log entries, and we want to keep track of something that happens to our user. We don't necessarily need to see the logs every time we get our user, but we can just go ahead and add new logs each time something happens. We'll go ahead and see an example of this where we go ahead and say session.queryOverUser, and we'll get the first entry, and then we'll try and access the user's posts. So we'll go ahead and run this. And so we can see whenever we run this query and we try to access the posts of the user, it does return this write-only collection, but only one query statement is being executed here, selecting just the user. And we can see here, if we try to loop over each post in our user's posts, it does throw an exception. And since this is a write-only collection object, we can perform all these actions on it. And the next loading technique we'll discuss is the dynamic loading technique. And instead of returning data from a database for the relationships, it actually returns a query object instead. This is really useful for large datasets with complex querying and filtering needs. So we can further customize the query on relationships. So this can be very beneficial for large social media platforms with many users and a large number of posts. So here we've just changed the lazy parameter to be dynamic. And then down here, we'll go ahead and add a new user to our database. In this case, I'm naming it Zek and giving them 50 posts. Then I'll go ahead and commit it. And then we'll have a user variable set to session.query of our user, and we'll filter by the name of Zek and get the first entry that pops up. And we'll try to access the post of the user. So we'll go ahead and run this. And we can see the query being performed to get the user is this one right here. But whenever we print out this users.post, instead of getting all 50 posts, it's just returning this specific select statement that would give us all 50 posts. So let's further customize this query to get exactly what we want. So let's say we want to further customize this query to get the top 10 recent posts from this user. So first what we'll do is we'll go ahead and comment out all this code right here. And then we're going to say recent post is equal to user.posts, and we'll go ahead and do .order by. And then we'll say post.id.descending, and this will return the descending order from the largest number to the least number. Ideally, you'd probably want some kind of date time variable here, but for simplicity, we're just using ID. And then we're going to limit to the first 10 results that come up, and we'll say .all. And then we will say for post in the recent post from this user. We'll go ahead and print the content from the post. So we can go ahead and run this. And we can see that it printed the content of the last 10 posts from this user. And then if we go ahead and scroll up and see the query being executed, we can see it right here with this select statement, selecting all the post information from posts. And then we're ordering it by post ID in descending order, which is exactly what we have right here. And it is also limiting by 10. So this does allow for more efficient and flexible operations, such as applying filters and limits, without loading all the related objects into memory. So this is really good in scenarios where you need to perform additional queries on the relationship, such as filtering and pagination, especially with large numbers of related objects. It is less suitable for situations where the number of related objects are small, and you typically need to access all of them at once. And this is not very useful for very simple use cases where the overhead of dynamic loading is unnecessary and you don't need to apply more filters on the query. So you can imagine something like a small blog site where each user only has a few posts. So whenever you access a user, you almost always need to display their posts. It also introduces unnecessary complexity and potential performance overhead. So something like this adds this extra .all on the posts when it's not really necessary, since we don't really need this relationship to have dynamic loading. Learning all these different techniques, you can find out which one suits your needs the best and which one performs the best in your situation. Each loading technique in SQLAlchemy has its unique SQL query implications. So understanding these can greatly enhance your application's performance and efficiency. Experiment these techniques to find what best fits for your use case. The options function SQLAlchemy is a powerful tool allowing you to dynamically customize your queries for optimal performance and data retrieval. Combine it with the right loading strategy to make your database interactions efficient and effective. If this video helped you, leave a thumbs up and subscribe for more. Thank you so much for watching.